Hey, good afternoon, everyone. Thanks for joining us today. And today's webinar's topic is the 2024 IECC versus the LECC for C406, and it's the start of a series. This webinar is recorded, and the recording is usually posted to the Code Adoption Toolkit within the next week or so with the slides. If there are any issues with audio, feel free to write me in the chat. My name is Erica DeLello, and I am a senior PM at Noresco. And I've been working with Anna with the Colorado Energy Office to put on webinars just like this one. We have a whole bunch of webinars coming up that we're working on, so definitely register for those. The series that we're starting today is this one down here, where we'll dive deep into C406. There is a slight change to the date. Previously, we had this on Veterans Day, and we're adjusting it to be the Thursday of the week before. So if you registered when it was on the 11th, go ahead and just move that on your calendar to the 6th, and you should be good to go there. Otherwise, we've got our typical Wednesday webinar series, the first Wednesday of the month, with all of these topics. We also are working on on-demand courses, where it's basically a platform where you can take classes at your own pace and get CEUs for those as well. So definitely keep an eye out for some of the upcoming new releases we have, and resources and trainings and all of that good stuff. If you are a jurisdiction looking at code adoption in the next year or so, we're here to help. We support the full suite of I-codes on a large variety of different ways. We can support your jurisdiction in moving forward to the latest I-codes. If you want to talk more about this, feel free to reach out to me and we can get something set up. And then here we have all of I know this is a lot of words on the screen, but we've come out with a lot of resources and we're still working on more resources. And this is just a snapshot of the latest. We're also working on LECC versions for some of this stuff, including the checklists you're seeing here. So that is well underway. There is a energy code resource survey out right now too. I'll be posting that in the chat shortly, and we'd love your feedback on what we should be developing next in terms of resources. So definitely fill that out. And last but not least is the Colorado Codes Helpline. This is an amazing resource that's available to anyone that works on projects in Colorado. If you're a homeowner and need to look at how to comply, or a designer and looking at how to comply, versus if you're working for a building department and need help with an inspection or a plan review, we're here to help. So if you submit a question through the QR code that's on the screen, a subject matter expert gets back to you in just a couple business days. Okay, so today's presenter is Anna McCullough, and she is a PE with over 14 years of experience in HVAC design and building performance. She is at Group 14 currently, and I'll go ahead and I guess just a couple of housekeeping items. If you do have a question to ask, feel free to write it in the Q&A, and we'll save those questions for the end of the presentation so we can get through all of the content. There's also that ability to raise your hand if you want to ask your question directly. And there is a survey window that pops up at the end of this webinar. If you could please take a minute to fill that out, it helps us to pick which webinar topics we're going to be training on, and also continue to improve on these webinars. And then lastly, I will be launching a poll. I'll keep that open for about 5 minutes, 10 minutes about that. And that just helps us understand how you found out about this. Okay, I'm going to go ahead and stop sharing and let you take it from here, Anna.
Okay.
Perfect.
So hi everyone. My name is Anna McCullough. I work for Group 14 Engineering. I'm an energy team leader. I have been supporting CEO in the creation of the Low Energy and Carbon Code as their technical advisor for the Energy Code Board. I've been involved in the 2024 IECC development, and so I've been around the code quite a bit. And yeah, today we're going to be discussing section C406. So first we're going to go through, I thought it would be really helpful for all of you to talk through the 2024 IECC section C406 so that you can understand kind of the basis of the low energy and carbon code. Then we will start talking about how the low energy and carbon code has amended the 2024 IECC. And then we're going to talk through the architectural credits. You saw on Erica's slides before that this series goes for a couple of weeks, and we will be breaking up these credits. We've all been there to the 4-hour classes to talk through all of the credits because I think we would every single one of us fall asleep. So that's the plan. Like Erica said, if you have any questions, please put them in the Q&A. And we will answer them at the end. I already see some questions coming in. So yeah, we appreciate that. We did get a question, so I'm going to go ahead and answer it just now. Do we know when the state low energy code be available as a complete code in PDF incorporating the amendments into the 2024 IECC? Erica, do you have an answer for that? I know we're waiting on some modeling from PNNL for those final credits in section C406.
Yes, I know that CEO has been working with ICC to create like an online version where it's integrated in the 2024 ICC, and that should hopefully be available within a month, but that's also pending, how many revisions and stuff are needed. So it's still tentative. We don't have a solidified date yet, but I know that that's in the works. So definitely before the end of the year, but hopefully within a month.
Thanks, Erica. Okay, great. So let's get into it. So pulling out my sleeves. Section C406, as created in the 2024, written in the 2024 IECC, has huge changes from what we were used to in the 2021 IECC. The first is that there are 2 sections of credits. There are additional energy efficiency credits, like we're used to in section C406. And then there are also renewable and load management credits. Under the 2024 IECC, renewable and load management credits are mandatory. Previously, if you were complying with the code via the performance method, you didn't have to comply. So section C407, you didn't have to comply with anything in section C406. But now under the 2024 IECC, we do have these credits that encourage demand side management. They encourage renewables on site to reduce the impact that the building has on the electric grid. So those credits are mandatory under the 2024. We do have the number of credits changing based on the occupancy type of the building and the climate zone. And for those of you who have read through the 2024, I don't have the tables in here because they're very overwhelming. But there is a large number of points required. So some occupancy types might require 90 credits that have to be developed using these packages we're going to go through in the next few weeks. Okay, so I made this little table to talk through, based on the 2024 IECC, and your building type or size, how you comply with section C406. So if you are greater than 2,000 square feet, but less than 5,000 square feet, You comply with section C406.1.1, which is the additional energy efficiency credits. You do not have to comply with the renewable and load management credits. If you are greater than 5,000 square feet, you do have to comply with both the additional energy efficiency credits and the renewable and load management credits. And then if you are a build out construction greater than 1,000 square feet conditioned floor area without final lighting or HVAC systems installed, you are required to provide 33% of the energy efficiency credits. You are not required to comply with renewable and load management credits. So if you're a core and shell building, no HVAC, no lighting, you only have to comply with 33% of the credits you would otherwise have to comply with. So that's the general 2024 IECC structure. So now CEO and the code board have amended the 2024 IECC to hopefully streamline things a little bit. The renewable and load management credits that we talked about under the 2024 IECC that are mandatory are now no longer mandatory, and they are combined in with the additional energy efficiency credits. So all of the credits are in one table, and you're not having to jump between sections to figure out which credits come from which table and how they interact together. There are increased point thresholds required as compared to the points that are required under the 2024 IECC. And then they also have created different point thresholds for buildings with primary gas, space, and or surface water heating. If you are using electric or heat pumps for your space and service water heating, you can comply with section C406 via a reduced number of credits. There are exceptions to this if you have backup gas heating. So a really common system type we see in schools are heat pump rooftop units with backup gas heat rather than electric resistance heat. You can use those that reduced threshold because you have primary electric heating. Your backup gas heat does have to meet the controls requirements of section C403.4.1.1, which is the HVAC section of the IECC that details when supplementary heat is permitted to run. So the heat pump can't keep up with the heat, the thermostat's broken, things like that. There's I think 4 exceptions there that describe how and when that supplementary heat should run. So that's the general structure. And now we're going to talk through how you know which table to use. And again, so I'm trying to make this a resource that you can look at and say, okay, I'm using gas heat in my rooftop units. I am 7,500 square feet. Which table do I use? So hopefully this helps. This is for all fully designed buildings. I do have some, the next slide talks about core and shell or first tenant finish. So if you have primarily gas heating or your primary fuel source for heating or surface water heating is gas, and you are between 2,000 and 5,000 square feet, you're going to use table C406.1.1.11. And if you are greater than or equal to 5,000 square feet, there are higher point thresholds that you have to meet, and that puts you into the second table. Again, if you have that primary fuel source as electricity, you look at the next 2 tables based on your square footage. And I'm not going to run through all of those points and tables, but this is available for you to use and reference. Oops. The core and shell or first tenant finish structure, if you are including central HVAC and service water heating for the tenants, you have to meet 50% of the credits otherwise required in section C406. You use the credit tables based on the heating and service water heating fuel type that is being designed. If you are not providing HVAC or service water heating, you only comply with 33% of the credits. And you're going to reference those credit tables with the lower point thresholds, which were the electric primary heating tables. If you are a first tenant finish, so this is a term that the code board added to the energy code, the low energy and carbon code. And what this means is you are the first tenant in a core and shell building. You and the HVAC and service water heating was installed under a previous core and shell permit. So this is kind of like this building was built and designed here, and then these people moved in. They're the ones that come after number one. You have to comply with 33% of the credits required, and you have to reference the tables required under the fuel type that was installed. So if you as a tenant are moving into a building that has primarily gas heat, even though you didn't design it that way, you need to comply with the credits for the primary gas heating systems. If you are moving into a building that permitted under section C407 of the 2021 IECC or later, you do not have to show compliance with section C406. If the HVAC and service water heating is being installed by the first tenant finish, so this is the accompanying, it's a hard word to say, section after number 2 here, then we are going to require only 50% of the credits required. And again, you need to reference the correct tables. If you are installing primary gas heating, you're going to have to meet those higher point thresholds. And we got 2 questions. Why is 2,000 to 5,000 square feet and greater than 5,000 square feet the size metrics used for the different thresholds? Are those somewhat arbitrary numbers that seem reasonable, or are they meaningful in terms of relatively building size to energy usage? So these are the values that were created by PNNL and DOE, who created the structure of this code for the 2024 IECC. They did use energy modeling to determine where that point threshold should be, but I don't know exactly what that energy modeling showed. But I do know that there was thought behind it, although I don't know the specifics of it. And then the next question is, so if permitting a full building, you need 100% of the credits, but if core and shell, then tenant finish, you need only 83%. 50% plus 33%. Yes, that's correct. You know, with the point thresholds that are required under the model low energy and carbon code, which are higher than what's required under the 2024 IECC, we found that it was going to be really difficult for core and shell buildings or for tenant finishes to come up with greater than 50% of those credits. You really need to use kind of envelope and HVAC and lighting all together to reach those higher point thresholds. So this is a way to encourage additional energy efficiency for these buildings without making them so difficult to comply that they can't be built. Thank you for the questions. There are also additional core and shell credit calculation requirements under the model low energy and carbon code. So again, these are still amendments. if you are providing lighting in your core and shell building that you're building for your future tenants, lighting credits can only be achieved for areas with final lighting installed at the time of at the time of the scope of this permit. So you can't get credit for future lighting installations. Where HVAC or service water heating systems are designed to serve individual areas. So if you are designing, you're putting in a rooftop unit that's going to be serving this northeast wing of your building because you know who's going to be in there and this is what you need to do for them. The total HVAC or service water heating measure credits are reduced in proportion to the floor area with those final systems installed. So what we're saying here is that we want you to be able to achieve credits for those systems that you are installing and to change the point threshold you need to meet based on how much of the building you are fitting out. So like I said, if we are installing final HVAC and service water heating in 25% of the building at core and shell because you know who that tenant's going to be, then we would calculate your credits to reflect that. Hopefully that made sense. Let me know if you have any questions. Under the Model Low Energy and Carbon Code, there are also renewable energy credit limits. So in section C406.2.8, which is the renewable energy calculation, there are, a number of credits that you can achieve by providing on-site renewables. So in this main kind of section C406.2, which is where we're talking through the structure of how C406 works, we also have this table that describes the maximum number of credits that you can achieve for renewable energy. And it's important to know that where this table is located, because if you are looking at the renewable energy and credit section, we do not have this table in there twice. So we want to make sure that people aren't counting. And the idea here is that we aren't just providing so many renewables on site that we aren't increasing the energy efficiency of the base building as a whole. So we want to make sure that we're bringing this to your attention. We will go back through this and how this is calculated and what this means when we get to the renewables and power section of this series. But I wanted you guys to know where it was. This picture has nothing to do with the credits. I just thought it would bring you all some peace going through this. So there is also a section within the code that basically states within section C406.2, we're stating that any of the credits that fall within these numbers have to be providing additional efficiency over what the base code requires. So you don't just get credit for providing the HVAC efficiency that just meets code minimums. You have to show that the efficiency of the systems that you are achieving additional credits for exceeds what is required by the base code. It's a lot of words to just basically say you don't get credit for just complying prescriptively with the code. And there's the tree for peace. Everyone absorb it before we get to the next slide. Okay. So this section is talking about demand response. So if you are achieving a credit under section C406 for renewable or for load management, so you are, within the mandatory sections of the code, we have to install thermostats that can respond to a call from the local utility to increase or decrease the temperature to reduce peak demand. But we don't have requirements around the use of those pieces of equipment. This section does require it. So if we are using the load management credits to achieve the credits required under section C406, you do have to configure that equipment to actually reduce the peak loads in the building. You don't get credit for just supplying them because they're already required as part of the base code. So that's why I have underlined here, capable of and configured to. You have to provide load management indicated on a peak period related to high short-term electric prices, grid condition, or peak building load. And how that is, there are a lot of, I'm so sorry, I'm getting over a cold and I might sneeze here in a second. Sorry in advance. There are a lot of requirements within the text of the code around how this needs to be coded. I didn't include them here because I didn't think that was necessarily the most relevant for you all in the time that we have available. But if you have any questions about that, we're happy to talk through that. The peak period should be initiated from the controlling entity, such as a utility or service operator. And there is exceptions for if a utility and service operator doesn't have a response signal available. So if you're in a building where that your utility doesn't have that capability, there are exceptions and instructions on how to reduce your building's peak load. Where communications are disabled or unavailable, controls shall continue based on a local schedule or building demand monitoring. So the grid goes down, you're on it, I don't know. The communication is broken between the utility and your building, something like that. There is a backup. You don't just kind of free fall into peak loads. You're going to be reducing your peak load through a schedule or based on local building demand monitoring. And then the schedule is adjustable. That schedule that I just talked about shall be adjustable without programming and reflect the electric rate peak period dates and times. So they want you to be able to adjust your building's peak demand, but have the information that you need available to you. So you need to know when your electric utilities peak demand periods are and what those rates are. If you are building a building in a location that does not have a response signal available or one of these demand side management programs available, local load management control has to be able to do one of these things. It has to have building demand management controls that monitor building electric demand and initiate controls to minimize monthly or peak time period demand charges. So we're basically looking at the data and determining how we can reduce that peak when the best time makes sense. It can be a local building schedule that reflects the electric rate peak period dates and times. And then you just have that schedule that's always in place. That's only available if your building is less than 25,000 square feet. Or it can be a binary input to the control system that activates the demand response sequence. So you say, yes, go. I did want to note, one of the difficult things about this is, if we talk about Excel's demand response program, you have to have a year's worth of utility data to enter into the program for them to accept you into the program. So starting out, your building is going to have to comply and be configured to provide one of these 3 items if you're using these credits to comply with the code. I also want to note too that these credits like we talked about, they're not mandatory, but also there are other credit pathways. It's not something that every building is going to have to achieve to show compliance. So it's just one of the pathways. But it is important. This is all amended by the low energy and carbon code. So this is a new section written for the low energy and carbon code specifically. And we will go back through it as we talk through those renewable and load management credits in the future parts of this series. And then the final piece of this model low energy and carbon code structure is that where credits are calculated based on equations, and there are quite a few, as you will see today, the credit shall be rounded up to the nearest whole number. So if you calculate that your credit is 1.5, or you achieve 1.5 credits, then you're going to round it up to 2. It does say that where a project contains multiple building groups, you need to weight those credits and your credit requirements on an area weighted average. My goodness. Credit E01, which is improved envelope efficiency. We'll talk through that. HVAC performance and lighting reduction shall be determined for the building as a whole. So these are the calculations that are provided based on modeling or based on a whole building. And then the credits shall be taken from the applicable tables or calculations for each occupancy and weighted by the building occupancy group floor area to determine your credit thresholds. So that's it on the structure. Is a lot of information. We're going to keep cruising through the envelope energy credits, but if you have any more questions, please feel free to dump them into the chat or the, oh, I see a hand raised. Great. Where is it? Can we, I don't know, Erica, can you unmute?
Yeah, I'm gonna go ahead and allow Demba to talk. If you go ahead and unmute yourself.
No, sorry, I it was a mistake. Sorry, I
Oh, that's
didn't
okay.
No
intend
worries.
to do that.
You're good.
Great. Okay. So if anyone has a question, you can raise your hand, put it in the chat or put it in the Q&A and we'll answer them as we go. Okay. So in the envelope credits, at the beginning of each section of credits is a description of how the credits can be combined. You cannot just combine E01 with E06. You have to put together the credits that are allowed to be combined. So we will talk through each of these credits and I'll remind you as we go through which credits they can be combined with. And, you know, as we get through these credits, you will have a better understanding of why they can or cannot be combined. So credit E01 is improved envelope performance, and this is through a modeling program, but we'll talk through that. That credit cannot be combined with any other credits. E02 is the component performance envelope reduction. So we're calculating the total UA of our building, like we did we used to do in ComCheck, and showing 15% savings, but we'll go through it. This one can be combined with the reduced air leakage credit. So you can have E02 plus E03. And then you can do any combination of E03, E04, E05, and E06. So you can kind of play with this a little bit to figure out what gets you the most credits, right? It could be that the UA E02 doesn't get you as many credits as combining E03, E04, E05, and E06. Or maybe you just want to add roof insulation and wall insulation and you don't want to reduce your air leakage, right? You can kind of play with this to figure out what gets you the highest number of credits based on your building's needs. See? So credit E01 is improved envelope performance based on ASHRAE 90.1 Appendix C. So ASHRAE 90.1 Appendix C is a modeling protocol for a full annual energy model simulation using local weather data to calculate the impact that your envelope has on your building's annual energy cost. And so this modeling protocol basically specifies that you are going to have in every single one of your energy model zones, you're going to have packaged single zones. It specifies the service water heating system, all of that, so that you can really show based on using the same HVAC system, based on the baseline building, baseline envelope prescriptive envelope performance, and my design's envelope performance, what my annual energy cost is. It does not you don't get any savings for additional reduced lighting power density, for example, or additional, you install a ground source heat pump system, right? You're not getting credit for the HVAC system upgrades that you're providing. It's all specified within this ASHRAE 90.1 Appendix C. The number of credits that are achieved are calculated via this equation. And we will go through what that is. So I said, for example, we have an 80,000 square foot multifamily building. The baseline envelope performance comes in at $88,000. The proposed envelope performance comes in at $82,720, which would be it's a pretty good reduction. You're going to achieve 60 credits using that calculation. So you're using the baseline annual energy cost minus the proposed divided by the baseline times 1,000. And that's how we get to our 60 credits. I popped in a picture of ASHRAE 90.1 here. The entire modeling protocol is fairly light, but you do have to provide a report that discusses all of your modeling inputs, provides a zone diagram, items like that. So this isn't just something that you can input the dollar amounts. You do have to actually provide a full report for the reviewer at the time of permit submittal. The next envelope credit is E02. So remember E01, and sorry, let me make this point before I forget. E01 shows us what the envelope as a whole does for the building in reducing the annual energy cost for a set HVAC system that doesn't even have to be related to what you install. And so you'll see why this credit cannot be combined with any of the other credits under the envelope section. You can achieve really high points with it. And you can, you're basically taking credit for all of the pieces of the envelope that you can otherwise achieve prescriptive credits for in the other sections. What is a little bit difficult for me to understand is why you would do the modeling protocol for ASHRAE 90.1 Appendix C and not just comply via the performance pathway. But I digress. I am an energy modeler, so C407 is near and dear to my heart. The next credit section is E02, component performance envelope reduction. And so this is where we are looking at the total building UA that we calculate in ComCheck, and we show a certain percent reduction. You do not achieve, so you have to achieve at least a 15% reduction as compared to the baseline envelope. So I made up a building in ComCheck. And it had, so all I did was pop in the envelope, and it had a 19% reduction as compared to the prescriptive requirements. So this would achieve, and you can see that highlighted here in this little green circle. This is what, if you go to the ComCheck website and go to the new ComCheck and scroll down to the bottom link with the new codes, you'll see this is what the outputs look like, or what the status looks like as you're inputting your comm check. Even though we achieved 19%, we don't get additional credits. We just get the base number of credits for this calculation. You could achieve 40% reduction and you still would achieve the same number of credits. Section E03, reduced air leakage. This one is fairly straightforward, but the number of points is difficult to achieve. So energy credits shall be achieved where tested building air leakage is not less than 10% of the maximum leakage permitted by section C402.6.2. And you calculate the number of credits you earn based on this EC adjustment. So we go through an example. I know this is horrible, and I tried to, they have the credit, like they have the calculation equations listed in the code, and I tried to put it in word form rather than like reading. You'll see it if you look through it. So it looks like a lot, but it's not that bad. So the credits you earn are equal to the E03 credits available in the table times the EC adjustment. The EC adjustment is the leakage savings fraction, which we will calculate, divided by the energy credit alignment factor, which is told to us based on the type of occupancy or the type of testing you're providing. So the leakage savings fraction is the lesser of the maximum leakage permitted for tested buildings based on so if you're multifamily, it's different than if you are a just commercial building, minus the measured leakage divided by the maximum leakage permitted for testing buildings. It's your percent reduction, right? Or 0.8, whichever is less. The energy credit alignment factor is 0.25 for dwelling and sleeping unit enclosure tests, or 0.37 for whole building tests. So on the next slide, this slide, I did this. I took a multifamily building and I said, we're going to design it and specify it to have an air leakage of 0.2 CFM per square foot. So we calculate our EC adjustment. First, we need to calculate our leakage savings fraction. 0.27 is allowed, minus 0.2 divided by 0.27 gets us to 0.26, which is less than 0.8. So we're going to use 0.26. Because we are a multifamily building, our energy credit alignment factor is 0.25. The EC adjustment is going to be 0.26 times 0.25, which equals 0.064. And the credits earned is 16 times 0.064, which is 1. So even with a significant reduction in the air leakage, we're seeing few credits using this calculation. Added roof insulation. So with this is a prescriptive credit where basically if you provide for insulation entirely above the deck or anywhere where you have continuous insulation, if you provide R10 insulation that is continuous and not interrupted by roof joists, you achieve these credits. If you do only have insulation that is interrupted by roof joists, you have to provide R13. If you only provide R5 or R6.5, if you're in joist, you achieve half of the number of credits that are available in this section. On this slide, I added in kind of some rules of thumb just to give you an idea of if you can get close to what's required. So if you are providing an additional R10 continuous insulation, depending on the type of insulation you're providing, that's around 2 to 3 inches of continuous. If you're providing R13 bat interrupted by joist, it's approximately 5 inches of bat insulation. And then I also took the requirements of section C402 with the prescriptive roof requirements, and I added in the continuous insulation or bat insulation for attics, so that you have a quick reference for what you should be specifying if you want to achieve this credit. So that'll be available. Credit easy. You see why I put the tree in there for a little bit of Zen before we got into the credits. Credit E05 is added wall insulation. So this credit requires for not less than 90% of the opaque wall area, not the total wall, not the total including the glazing, just all of the opaque wall area. You are required to provide an additional R5 continuous insulation, or you can achieve half the credits by providing R2.5. So I did this. It looks terrible and I'm so sorry, but in my defense, so does the table in R4, section R402. I did note here that depending on the type of insulation that you're providing and you're using, R5 continuous is about 1 to 1.5 inches. But I put in here kind of all of the above grade wall continuous insulation, what that R value would be if you were complying with this credit. So that'll be available. I'm so sorry it looks so bad. And then the last credit we're going to talk about today before we can start going through questions, if you guys have any, is improved fenestration. So this one has a specific table, section table C406.2.1.6, which we will go through in a minute. But all vertical fenestration, I'm sorry, let me back up. The area weighted average U factor and solar heat gain coefficient for all vertical fenestration in the project shall be less than, equal or less than the value shown in the table. Where vertical fenestration, where you have some sort of shading in the project, if your projection factor is not less than 0.2, you're allowed to have a higher solar heat gain coefficient than what's in the table. And then you also have to pay attention to the area weighted visible transmittance of all of your glass, which is also specified in the table. You can be equal to or greater than the VT allowed in the table. I did want to know, because a lot of times, you know, we'll be talking to project teams and they will think that their glazing is better than what it is because they're looking at a center of glass value. So when we're talking about glazing when we're talking about the energy code, we're talking about the entire glazing assembly, which includes the frame. And as we know, frames are really great for reducing our solar heat gain coefficient, right? They allow less sun in because they're opaque, but they are bad for U factors. So if you are looking at a type of glass, a very quick rule of thumb, and do not use this as the Bible, this changes based on how big your glass is, how big the window is, the amount of framing you have, all of that. But if you are looking at a glazing specification and you want to estimate if it will come in this range, you can add 0.12 to your U factor for a thermally broken frame. It's a pretty good frame. And subtract solar heat gain coefficient 0.02 from the solar heat gain coefficient specified as the center of glass. Now, this changes, right? If you have a lot of frames, so if you have a big storefront system and the glass is all broken up in a very beautiful architectural way, this is going to reduce your or increase your U factor significantly, right? The warmest place in a piece of glass is the center of your glazing assembly. And the coldest place is out by the frames because they're just metal and you're just letting that cold come right through even if they're thermally broken. But this is the table for climate zones 4 to 5 and 6 to 7. So you'll see that the maximum U factors are changed based on fixed or operable. And then we also have the maximum solar heat gain coefficient and minimum visible transmittance. We got a couple questions. Is NFRC 100 test still accepted? That is a great question. And I want to say yes, but I'm going to triple check and get back to you on that. I cannot remember off the top of my head, but I believe it is. Let me just make a quick note about that. And if we have a minute, I'll pull up the code and double check while we're still on the webinar. And then we have another question. Can a U 0.26 be achieved without going triple glazing? You can potentially get fairly close with an argon fill. A warm edge spacer is going to help you, you know, really, and then providing a really good window frame that is potentially like doubly thermal broken with that warm edge spacer, that's going to get you a whole lot closer. But I can do some digging too and see if I can find any products that would get you there. Again, it really matters. It's really going to depend on the how large your glazing is, right? And actually, you know what? You can get there with vacuum glazing. So that's an option as well. Sorry, I just thought of that. Good questions. But that's it. That's all I had. So we have 9 minutes left. Are there any additional questions? If you have questions that you think of or things that you want me to cover in the next webinar, you want to talk about them together, you can shoot me an email, you can call me, my information's right there. But I'm going to pull up the code and look up this NFRC 100 question while we are seeing if there's any additional questions.
Perfect. Thanks, Anna. There is one other question that came up. Just wondering if there's a flow chart available to navigate all of this.
Yeah, so I created a you know, those kind of bullet points in this presentation to help. Erica, I'm not sure if you all are creating a flow chart for navigation, or if this is what we've got so far.
This is probably what we have so far, but Donald, I would encourage you to submit that request in that resource survey that I posted in the chat. That helps us kind of see how we should use CEO's funds and what resources to create, especially focused on the LECC. So if you'd like to see that happen, that's a great place to start in requesting it.
And I did confirm that NFRC 100 is still accepted. In fact, it is required.
Yeah, perfect. Okay. Okay. Anna and I will stay on the line for the next couple minutes. If anyone wants to raise their hand or submit another Q&A, we're here to help. I'm going to go ahead and stop the recording.